Okay guys, today we'll be doing 4.1 differentiability, and we're going to be dealing with graphs. I call this the choo-choo lesson. You'll see why in a bit. To start out, let's start off by writing the rules that makes a function continuous, okay? So that'll be from back in chapter 2. Remember, there are 3 rules that need to be set in order to make a function continuous. Let me get my little pen here. Okay, first rule. Remember, the limit must exist. So the limit as x approaches c of some function must exist. Okay. Number 2, there must be a point at that value. Remember, c is going to be some number. And the last one is that the point and the limit equal each other. Okay. And that's things that make something continuous. So tell whether the functions down here are continuous. The first one here. Is this one continuous? Well, no. It does have a limit right here, but it does not have a point. So f of 1 does not exist. So it's not continuous. This next one over here. First thing you would do is check if it has a limit. And remember, this less than sign means that is a function using from the left. This greater than sign means this is a function for the right. So if we want to check the limit, we got to check the left and the right. So the left side approaches 4 times 1 squared is 4. Now we plug 1 into there. Okay, 4 from the left. From the right it approaches -1 plus 2, which is 1. Okay, so this one is not continuous because the limit, and notice my notation here because people were doing bad on it recently. The limit as x approaches 1 of our function g of x does not exist. So then we can write not continuous because this does not exist. Okay, let's go to our next slide here. Okay, differentiability. Okay, I have a bad definition here for you, but it works. The graph must be continuous. So remember, you can draw it without taking a pencil off the paper, and smooth. Okay, smooth meaning can't do any little sharp turns or anything. Yeah, like that's smooth. Now, something that's not smooth would be something like that. That would be not differentiable. It needs to be smooth. Here's why I call it the choo-choo lesson. The function was a train. So like let's say this was a train that was on the function. It should be able to go through the entire graph if it was differentiable. Notice on this one, it's a train. It's going on the graph. It's going to wreck right here, right? Because it's a sharp turn. Okay, so no sharp turns, and also an important thing is no vertical tangent lines. Okay, differentiability rules. Okay, first thing is must be continuous. So you have to have those 3 rules we just spoke about. The limit as x approaches c of the function exists. Okay, that's the first one. Number 2, f of c exists. Okay, and the third one, the limit as x approaches c of our function equals the point. Yeah? Now here's the only other thing. So this means it's continuous. This is the continuous part. Okay, now you have to check to see if it's continuous. Then you can check if it's differentiable. Here's the differentiable part. Okay? There's only one rule. Remember it says that it needs to be smooth? That means that the slope on the left-hand side needs to equal the slope on the right-hand side. That would mean that it's smooth. Notice right here, the slope from the left is not the same as the slope from the right. That's why it's a sharp turn. So if we're talking about slope, we're going to be talking about the derivative of the function. And if we're going to talk about from the left, we need to use limits. The limit as x approaches that c value from the left needs to equal the derivative as x approaches that value from the right. So there is the differentiable rule. So first you need to check the three continuous rules, which you know how to do because we did several lessons on it. Then you need to check if it's differentiable by checking if the slope is the same on both sides. Okay, let's do some of these on a graph, okay? So, first one, is this continuous? That's the first thing you're going to ask yourself. Is it continuous? So, you would say that this is not continuous. You have to take your pencil off the paper, right? And you're going to have to tell me why it's not continuous. Well, in this case, the limit as x approaches -2 of our function does not exist. Therefore, it is not continuous. And since it's not continuous, it is not differentiable as well. Okay? So you need to be continuous in order to be differentiable. And remember, do your math notations correctly. Okay, this next one. Well, the first one, it does have a limit. From the left and the right, it does approach the same value. Now, but it does not have the second rule there. F of 1 does not exist. Yeah? So, since it does not have a point, it is not continuous. Therefore, it is not differentiable. Okay? Let's go to the next one. Okay, this one. It does have a limit. Limit's 1. It does have a point. It's 2. But they do not equal each other. So, let's make sure you guys write this correctly. The limit as x approaches 2 of our function does not equal f of 2. That's the third rule. You guys are really bad at writing that. The limit as x approaches 2 of the function does not equal the point. Therefore, since it fails the third rule, it's not continuous. Therefore, it is also not differentiable. Okay, this one right here. Okay, it does have a limit. It does have a point, and they are equal. So this one is continuous. Okay? Now, but here's the problem. It has a sharp turn. Therefore, the slopes on the left-hand side are not equal to the slopes on the right-hand side. These slopes are different. One's negative, one's positive. So, it's not differentiable. We need to write y. We need to say the slopes on the left-hand side, now we're talking about at 1, the value 1. The slopes on the left-hand side, notice that the limit as x approaches 1 from the left. When we're talking about the slopes, the derivative does not equal the limit as x approaches 1 from the right. We're talking about the slopes as well. Make sure you're using the correct notation. Therefore, it's not differentiable because the slopes do not equal each other from the left and the right. So if you are not understanding this, this means the slope on the left does not equal the slope on the right. And remember, you cannot use verbal writing like this. You guys have been doing it on the test. You need to show your mathematical writing. Yes, like this. Okay, let's see if I got any more here. Okay, this one over here. This is my last slide, I believe. Oh no, I got one more after this. Okay, we're going to be talking about this point right here. That is a sharp turn. Now, I know it's not a very sharp turn, but it's still the slopes on the left-hand side, these slopes, are not equal to these slopes. That's why it has that little tiny sharp turn right there. So, the function is continuous. It has a limit, it has a point, and they're equal. But the slopes on the left, so the limit as x approaches, looks like we're talking about 1 again. 1 from the left of the derivative, so the slope from the left does not equal the slope from the right. Okay, so therefore it is not differentiable. Okay, now let's come over here. This one is, if you notice, it is continuous. You can draw it without taking your pencil off the paper. Okay, it is continuous. And also this graph is smooth the whole way through. Yeah, so it is also differentiable. The slopes from the left and the right are always the same. Okay, let's go over to my last slide here. Tell whether these functions are differentiable, neither or both. Okay, well, some of these, that one is continuous, and that one is going to be smooth as well. If you just think about it, what a graph of a parabola looks like. So this is continuous and differentiable. Okay, that's supposed to be a little and symbol. Okay, this one over here. Notice this is not continuous because if you were to separate this top portion, oh shoot, I canceled the wrong one out. Should be the x plus 3 cancels with x plus 3, leaving you with just x minus 3. Now, but that means that there was a hole. There's a hole at negative 3. So that means it's not continuous. And since it's not continuous, it's also not differentiable. Okay, tangent. I made you guys all graph tangent because of that test practically. You guys should know now that tangent is filled with vertical asymptotes everywhere. So this one would be not continuous because there are vertical asymptotes. So since it's not continuous, it's also not differentiable. Okay, and the last one here. Well, this one would be not continuous as well because what if x equals 0? Yeah, you can throw a 0 on the bottom. That means that there is a vertical asymptote somewhere. So it's not continuous and not differentiable. Okay, and that's everything.